Welcome everybody, and thanks a lot to Kevin for inviting me. I am Ferdinando Papale, and I mostly work as a .NET developer for MongoDB. I work from Copenhagen, Denmark, so it's 1 hour later here, but I'm actually Italian. And the reason why I'm here is that I would like to tell you a little bit about why we decided to move from using aisle weaving to search generators in the .NET SDK of Realm. I will talk about Realm a little bit more in details later, but essentially Realm is an object-oriented database that has been created with mobile in mind. But I'll tell you more about it later, as I said. Just to set up the context, I'm going to talk about code generation in .NET. I'm not talking here about code generation in the AI sense, but I'm talking of a much more dumb one. This is because both search generators and aisle weaving are two different techniques that can be used to generate or alter code in .NET. They do it in very different ways. They have their pros and cons, and also I will tell you why we decided to use them in the first place in the library, and why we decided to move from one approach to the other one. But before all of this, I will introduce a little bit what is aisle weaving, what are search generator, and what is Realm. Okay. First of all, what is aisle weaving? Every time you compile some .NET code, this gets compiled first to something called intermediate language. And then, depending on our configuration, it either gets compiled to machine code at runtime. If you're using JIT, that is probably the most common way of compiling code. Or it's compiled to machine code ahead of time if you're using AOT. That is something that is getting pushed more and more recently. IL is very similar to Java bytecode if you have experience with it, and it looks a lot like assembly. I will show you in another slide how it looks like. IL weaving is the process of modifying the IL code to do practically anything. You can practically add classes, change the behavior of methods, add attributes, remove attributes, and do practically everything. So it almost feels like magic. And one important thing to remember about the IL weaving is that this is something that happens after compilation. And I would say it's given because you need to have IL code in order to have IL weaving. So why would you want to use IL weaving, or anyway, why would you want to use a library that is providing this IL weaving? Well, most of the time it's very useful to generate repetitive or optimized code. So just to give you an idea about how IL code looks like. So if you define a class like the one that you see here on the left, where you have a property with a getter and setter, just a simple property. So what you have here on the right is the corresponding IL code. Now, you don't need to understand what is happening, but this was just to give you an idea about the fact that IL code looks like assembly. It's a series of instructions. It's very difficult to understand what is happening if you don't have experience with it. And I also don't understand fully what is happening here. But it was just to show you how it looks like.
Okay. Hey guys, how you doing?
Hello.
Hey.
And so now, just to give you an example of a library that is using IL weaving as maybe a little bit more practical. So there is this library called propertychange.fodi. And if you ever worked with any MVVM framework like Xamarin, Maui, Avalonia, Uno, and so on, you know that if you want to bind your objects to the UI, then your class needs to implement iNotify property change. So iNotify property change is an interface that contains only one event, that is this one that you have here, the property change event. And the contract here, like the idea here, is that the UI subscribes to this event, and the class itself raises this one every time one of the property it has changes. So in this case, every time the name changes or the age change, this event should be raised with the name of the property that is exchanged. So the UI can essentially refresh. It will get the new value of this property and it will show it on the screen. Now, if you have to do this process manually, so implement erasing the notifications correctly, then your code will look like what you have here on the right. So every time you need to modify the setters and getters of your methods in order to call the, in this case, it's calling the onPropertyChange method that is invoking the event. You can imagine that this process is not particularly user-friendly. It's a lot of code that is repeated for all your properties, so it's very annoying to write. It's also error-prone, especially if you have dependent properties. So, for example, if you have properties that are dependent on each other, so if you have a full name property that depends on a first name and a second name, then it also gets a little bit more complicated. So what propertyChange.FOD is doing is going into the DLL that you created, so into the finds all the classes that are declared implementing this interface, and then it's modifying the setter and getter so that they raise the property change notification, the property change event correctly. So essentially, in your ID, so this is IL weaving. So this is all happening after compilation. So in your IDE, you will still only see these few lines of code, but your code will behave like if you had written all of this. But as I said, this is still hidden from you. You are not able to see this in your code. You are actually able to see only if you use some other techniques, let's say. Okay. So now, how would you see IL code? How do you see Swift code? Well, it depends. What do you want to do? If you're just curious about how IL code looks like, or you have like a very simple code, then you can use something like SharpLab, that is an online tool for an online.NET playground. And I lost the screen with that, is this one here. So what you can do here is that you can type out something. So in this case, let's put a simple property. And what you have here on the right, you can see the corresponding IF code. It's not really easy to read, but for example, here you can find the getter for the name property, and you can find the setter. And if you hover over the body of the method, you can see that it gets this gray background, and the getter method has been also highlighted on the left, so you can see what does a piece of code corresponds to. So this is just this is useful because actually with SharpLab you can do a lot of other things. So this is one of the things that you can do with SharpLab, but you can do a lot of other things. Okay, now if you are curious about how IF code looks like in your project, or if you want to see what happens with after weaving, then you need to use something like a decompiler. So what I have here is a project where I've added the propertyChange.FOD library that I've described some slides ago. And then I declared this class called person_propertyChange that is declared implementing this iNotify property change. So I have the event here, and then I have two simple property, name and age. Now, if you want to see what has happened with weaving, then you need to open a decompiler like ILSpy, and you open the DLL. Then you need to navigate to the it just is divided into namespaces and then the classes. So you go to your namespace and then your class, and then here on the right you have the IL code corresponding to that DLL. Now, if you look at the IL code, it's very difficult to understand what is happening. So you can also go to the C# view that shows the compiled way. So this is much more understandable. And for example, if you look at the name property, you can see that the setters and getters have been modified. In particular, the setter, what the setter is doing is, if the new value is different, so it's not equal to the previous one, so the one that was in the backing field, Then it's setting the begin field and it's calling this onProperty change method. That is also something that that Fodi has added, property change.Fodi has added, and that is invoking the event. So sorry. So what is happening here is that essentially property change.Fodi has created all of this so that the property change event is raised correctly for both the name property and also the age property, the one that is here. As you can see, algorithming is a process that is essentially invisible to the user, because if you're not using the compiler, you really don't know what has happened to your code. But this was just to give you an example. Okay. So this is weaving. Now, instead, what are sort generators? So sort generator are a compiler feature that was added with .NET 5, and that are essentially something that plugs into the compilation pipeline to eventually generate new code. The way that it works is described into this schema that I took from the documentation. So what is happening here is that when you have sort generator in your code, there is a first compilation step. Then there is a sort generator step of the compilation in which the sort generator is passed something called a compilation object. With this compilation object, the sort generator can analyze your source code, so can see everything that you've typed. And then eventually they can generate new source code that is added back to the compilation, and then the compilation continues. So sort generator essentially can add source code file to the compilation. So one big difference with algorithming is that they cannot modify what's already there, but they can add new files. So they're only additive. Another important difference is that sort generators, the sort generation process happens during the compilation, while instead with the weaving that was happening after the compilation. Now, why would you want to use a sort generator, or why are they useful? Well, they're useful for very similar reasons to that the IL weaver, let's say, are useful. So they're very useful to generate repetitive or optimized code. To give an example about a library that is using a sort generator that maybe you're using, there is system.text.json. That is a library that you could have guessed is used for serializing and deserializing JSON. The way that, and in .NET 6, so I think it was 2 years and something ago, they decided to add a sort generator to this library. And I don't want to go too much into details, but the way that it works is that obviously you need to define the class that you're interested in serializing and deserializing. Then in other parts of your code, you need to create a context that is deriving from this JSON serializer context. And you need to give this attribute that contains the type of the object that this context should be responsible to. Then when you are serializing, you need to pass this context here. So yeah, it's not very, it's not very important the way it works, but it's interesting to know the reason why they did it. So before .NET 6, this library already existed, and it was based on reflection. The reason why they decided to add the sort generator to this library is essentially performance. If um, if you're using reflection, that this means that all the property discovery was done at runtime. But if you think about it, all the properties are already known at compile time, and you could even type the serialization yourself. It's just something that we normally don't do because it's an annoying process. So what the sort generator is doing is that it's finding this context class, and then it's generating the rest of the class that inside contains already the serialization code already typed out. And it is much more efficient than having it done, having this property discovery at runtime. And according to the Microsoft benchmarks, at least, this should be at least twice as fast as the previous approach based on reflection. Okay, this was just to give you an idea. about the library that is using source generation. So how do you see source generated code? Well, this really depends on your IDE. If you were like me and you were using Visual Studio Code for Mac until it was discontinued, then you were out of luck because it was not possible to see the source generated files. If you're using Visual Studio for Windows, then it's quite easy because you can go inside the dependencies and then under analyzers, that maybe it's a little bit confusing. And then under the library contains source generator, you're able to see the generated files. That also have this beautiful yellow banner that tells you that the file is generated, so you cannot modify it. Okay, so now you have an idea about source generators. You have an idea about weaving. Now you need to understand a little bit more about Realm. So what is Realm? Realm is a reactive and object-oriented database that has been created mostly with mobile in mind. So with devices with, let's say, limited capabilities. It's available for a lot of programming languages, among which C#, of course, otherwise I would not be here. Kotlin, Swift, TypeScript, and so on. And also it's available for a lot of different platforms. It has a lot of nice features, among which device sync that allows to automatically synchronize the objects between multiple devices and with Atlas, so MongoDB on the cloud. Those characteristics, though, are not very important for the rest of this talk, but there are two things that you need to remember about Realm. So first of all, Realm is object-oriented. And I will show you I will show you later how does it look like. But in this case, what it means is that when you're working with Realm, you are working directly with C# object. You don't have any ORM like you would have with a database that is based on SQL. There is no translation layer. You are directly working with objects. And this is one important feature that you need to remember. The second important feature is that Realm objects are live. What does it mean that Realm objects are live? It means that the objects always reflect the latest available data in the database. This means that when you have a Realm object, and you access a property, you're accessing that property in the database. If you're setting the value of a Realm object, you're setting this value in the database. This is very different from the approach that you will have with the traditional database based on SQL. Because if you do a query with SQL, then you get some data, and this data reflect the state when you made the query. But then obviously the database, something will happen in the database or something, but that's totally independent what happens to your to the objects that you got. And this is very different than what happens with Realm, where everything is live, objects, collections, and queries. So I have also a small example to show you what I'm talking about, because maybe it's easier to understand it like this. So maybe going line by line, so it's maybe everybody can follow. So here I'm just getting an instance of the database with realm.get instance. Then I'm creating a GUID that I'm using as the primary key, so it's easier to find the object. Then I'm calling realm.write, where write is essentially the equivalent of a write transaction. And inside this write transaction, I'm adding something to my database, so to my realm. And I'm adding a person where the ID is the GUID that I just created. The name is Mario, and the age is 22. I hope it's clear so far. Then what I'm doing here is that I'm calling realm.find that allows to find an object given the primary key. And this is my variable person1. And then I'm doing it twice. I'm doing it twice just because now I want to have two different C# objects, right? So I can assure you that there is no caching inside this find method. I can also, I don't know, print a reference equals if you want, but these are two different objects, right? And then what I'm doing here is that I am calling I'm opening another write transaction, and then I'm changing the age of person1, and I'm setting it to 40. Before it was 22. And now I want to run the code. If I can move the zoom commands. Yes. And what am I doing? 1 second. The zoom commands are in front of everything. Okay. So what I'm doing here at the end is that, first of all, I'm printing the age of person 1, and this is 40, but I would say this is not surprising because I just modified it. The thing that is maybe a little bit more surprising is also that person2.age has been modified from 22 to 40. And this is due to the fact that when you do this query, we're not copying all the data that is in database in this object. But we are essentially, every time you call person.age, you are going to the database and getting the value from there. So everything is live. There is no copy being done. And this is also something that is important for the rest of this talk. There are also a lot of other things that I could say about Realm, but this was just to give you a very brief idea about how all of this looks like so you can understand the rest. Okay. And that was it. So now you also have an idea about what is Realm. Now you have an idea about what is Realm, you have an idea about generators, you have an idea about weaving. And we need to take a look at the reason why we started using these techniques, these code generation techniques in the first place, and why we decided to move from one approach to the other. So when the library was created, we first used IL weaving for the model definition. In particular, what you see here on the left is the way that developers could define the model of their database. Essentially, the way that and this one looks almost like a plain old C# object, right? You have your class, you define the properties with getters and setters. There are also attributes like primary key because it's a database. And maybe the only difference between this and the C# object is the fact that you have this the class needed to derive from this realm object class. Okay, so what we were doing with weaving, essentially, we were changing the way that the getter and setter works in the way that you see on the right. Essentially, we were modifying the getters and setters to call the get value and set value methods. Without going too much into details, what we're doing essentially is so what these two methods are doing is getting into the database to retrieve the value or setting this value directly into the database. Now, one thing that you need to remember, though, about this is that what you see here on the right, this is an extremely simplified version of what is happening with Weaver, because the logic inside the getters and setters is actually much more complicated because it depends on various parameters, among which the type of the property, because this gets much more complicated for a collection. It depends on the status of the object and so on. So, I'm sorry. So this gets much more, this gets actually much more complicated in reality. And another thing that I forgot to say before is that Realm is open source. So if you're curious about how all of this works in practice, you can also just go on GitHub and take a look. Okay, so now, so why the reason, the question is, so, okay, this is what we're doing, but why we're doing this? Well, essentially, we decided to do this because we wanted to give developer the best experience possible. And the way to do that is to let developers work with something that looks like a C# object, even though behind the scenes, we are retrieving and setting the properties directly into the database. Essentially, what we're doing with weaving, and also we are doing also with generators, is hiding a lot of complexities of the Realm library behind the model definition. So we are just doing this to give developers better experience by hiding all the complexity in a way that developers actually cannot see. So now, how this looks like on the IL level? So what you see here on the left is the way that the IL code looks like when you define it. So if you don't have Realm. And then on the right, you have how it looks like after the weaving. As you can see, it gets much more complicated. And this is for a string property. This will be much worse if this was a collection property. You don't need to understand what is happening here, but this was just to to give you an idea about what is happening. Okay, so as I said, algorithming has been an extremely powerful technique for us because it allowed us to hide a lot of complexity behind the model definition. So also because essentially this is what makes the realm objects live. This is what makes the object essentially a shell, because every time you call a property, you are getting the value or you're setting the value. So this was extremely powerful for us, but also algorithming has some major drawbacks. First of all, as you have seen, the AL code is very difficult to look at. It's very difficult to understand what's happening because it looks like assembly. You don't really understand too much what is happening if you don't have experience with it. And for this reason, it was also very difficult to extend this part of our code because you are working with essentially with instructions. And here on the left, I have taken a screenshot from our source code where we do, I think it's the weaving of the getter property. As you can see, you have a lot of inserting instructions in a certain place and so on. So it's not really user-friendly. Another problem is that this is a black box. So the changes to the intermediate language are not visible to the final user. You can see what is happening to your code only if you use something like a decompiler, but that's not something that many developers will do, I suppose. Another problem is that you have interferences. So if you have multiple waivers in your code, they could be issues, because if you have multiple waivers that are changing the same part, the same sections of IL, then there could be a problem. And so maybe there needs to be a sort of I don't want to say communication, but some synchronization between the viewers themselves so that they don't step on each other's feet. And this is also something that we had to do, for example, with property change.fodi that I've showed before, because both Realm and property change.fodi are trying to implement iNotify property change. But if both weavers are doing it, then it will not work. So we had to find a solution for this. Another problem is that this is not debuggable. You cannot really use debugger to debug this code because there is no source code to jump to. And there is also one final issue, and that is weaving is not part of the compilation. So something that developers ask us every now and then is, well, why can't I use an interface as the instead of a base class? Well, essentially, this is the reason. weaving is not part of the compilation. So this is something that has to happen after the compilation is done. So if we declared an interface, then this means that the developers will need to implement this interface in order for the code to be compiled. Otherwise, without compilation, there is no weaving. And so for all their model classes, they will need to have something like this. So they will need to have the right-click implement interface, and then we'll have all these anti-implement exception. Then what we will do is that we will go into the code and then adding the correct implementation of these properties. We decided not to do this. Well, first of all, because this looks horrible. This gives a really bad experience, and it almost feels like magic because you have all these throw not implement exception, and then when you actually run it, it works. So it feels very strange, and it looks horrible. And another reason is that all of these will be extremely annoying to do, because at the moment the only thing that we're doing with weaving, almost the only thing actually, is changing the getters and setters. But now we have much more work to do with Weaver. That is something that we don't want to do because it's extremely annoying to work with. So these are some of the reasons that made us decide not to go this route. And this is why we needed to have a base class, because essentially a lot of the internals of Realm are in that base class. Okay. So now you understand what were our problems with Weaver. At some point in 2020, I think so the surge generators, or 2021 now, I don't remember correctly, they announced with the .NET 5 announced surge generator. And at some point, we decided to move, to change our approach from weaving to surge generators. The change to source generators also allowed us to do some changes to our source code and also to the model definition. So what you have here on the left is the model definition that you had before with the approach. So you have your class, the properties, and then you have the base class, Realm object. With the new model, essentially the property definition is 100% the same. The only thing that is different is that now you need to have a partial keyword here, and then instead of having a base class, you can have an interface. So this is something that we wanted to do for some time, but we couldn't do before. And why could we do it now? Well, we could do it now because the way the source generator works is that it goes into the user source code. It finds all the classes that are declared implementing this interface, and then is generating another source file with the rest of the implementation of the class that contains also the implementation of this interface. One thing maybe two things to remember about this is that, first of all, this works 100% the same way as before. So for developers, this is the same kind of experience. And also this is moving from the old approach to the new approach is quite easy because you just need to have the partial keyword, and then you need to have the to modify your base class to use this interface. But it's quite easy, I would say. So what I have here is just a very small part of the code that is actually being generated from being generated by source generator. As you can see, we have the implementation of all the properties of this iRealm interface. We also implement the iNotify property change interface that I've said before. It doesn't matter too much what is here, just to show you a little bit what is happening. So as I said, source generator have some very good advantages over weaving. Well, first of all, the code that is being generated is actually readable, and it's also debuggable. It's debuggable because now the debugger has source code that it can jump to compared to before. And also, it's much easier to work with source generators because you are working with something that is producing C# code. And if you're a C# developer, you know how C# code looks like. You know the way that it should look like, right? And so it's much easier to work with source generators, so they're much more extensible, and they allowed us to introduce support for new features in this part of our source code regarding the model definition. For example, add new data types, or also support for nullability. They allowed us to do this in a much easier way. They're also part of the compilation pipeline, and this means that they're much less brittle. There is no competition essentially between multiple source generators because they are only additive, and this is something that is being pushed by also by the whole ecosystem. They also have some issues though. One smaller things, and that maybe is more from the let's say from our point of view, is the fact that you're working with text generation. And I mean, as long as the code compiles, the code that you're generating compiles, it doesn't really matter, because you could write the code the way that you want without spaces and so on. But if you want to let developers read your code that you're generating, and if you want to make it readable, essentially, you need to spend some time because you don't get any help from the source generators regarding auto formatting. So you need to take care of the spaces, the new lines, and so on. I have to admit this is a small things, but I thought it was worth mentioning. Another problem with source generator is performance. This is because with weaving, this was happening once after compilation. With performance, source generators can run multiple times even while you're typing. And this is because source generators are actually adding something to the compilation. So they, for example, could add the actual implementation of interface. And if this will run only at compilation, then you will have compilation errors until you compile the first time. So this is something that you need to consider when you work on source generators because they cannot do too much work, otherwise the whole IDE will slow down. And the biggest issue is that source generators are only additive. They can only add source code. They cannot modify existing source code. And this also means that I slightly lied to you when I say that we moved to source generators. I mean, we moved to source generators, but we didn't move 100% to source generators. We couldn't do it. And why is that? Well, if you look at the model definition that we have here on the left, this is the one that we had before with weaving, right? So you have your class with properties, with getters and setters deriving from Realm object. Now, if we wanted to have a 100% source generated approach, then you would have something like you have here in the middle. So you have your partial class, you have your interface, that's not a problem. But then because if we couldn't keep the property definition the same, and we couldn't do it because if the property is already defined, we cannot define a property with the same name, right? So what we could have done is to define some fields, like some private fields that you have here, and then we will generate a property with the same name, obviously capitalized and without the underscore, that is a realm property. And this is also actually something that is done by, if you work with Maui or Xamarin, this is also something that is done by MVVM Toolkit. So that inside it has some features to allow to auto-implement unnotified property change. And this is the way that they decided to go. In our case, we decided not to do this for a couple of reasons. First of all, these baking fields, they actually have sense. They actually make a sense in the case of the unnotified property change because these are the baking fields of the properties. But in our case, these baking fields are just a blueprint. They don't have any practical use because we don't need baking fields for realm properties. So they will be there and they will not be used. So it looks strange. Also, they it will be more difficult to move from the previous model definition to the new one because you need to change all the properties to fields. And also it will be more complicated because, for example, you should be able, with realm properties, you are able to define any kind of accessibility. So your properties could be public, private, protected, and so on. Well, here you will need to define new attributes to let you say what kind of properties we should define. And overall, we thought that this will be a bad developer experience because it doesn't give this impression of working with a normal C# object. And so this is the reason why we decided to go for a mixed approach. This is one that I've shown you before, where you are still using the same properties as before, and the only difference is this partial keyword and this iRealm object interface. So this is, I just said this is a mixed approach because we still use a little bit of weaving, and we're still using the weaving to modify the setters and getters, but now what we're doing with weaving essentially, well, everything 100% that the setters and getters are doing is actually relaying the access to a property with the same name on something called the accessor. The accessor is also something that we are generating. So, and one thing that maybe is not maybe must be said is that this is 100% what is done by the Weaver now. So this is the same for all properties. What I was showing in the beginning for the Weaver was a very simplified version. So, but what you see here is 100% what is done by the Weaver, and this is extremely simple because this is just calling the essentially the property of the same name on another object, and also this is the same for our property, independently of the property type and independently from the state of the object. So I don't want to go too much into details, but the accessory is also something that we are generating. So essentially, all the complexity that we had before in the Weaver now are in this accessor. That is something that we're generating. So it's much easier to work with and to extend because this is the accessor is just written in plain old C# code. There is no IL involved. So this is much easier. But it still gives developers the same kind of experience while greatly simplifying our work because now we can work on this part of the code in a much easier way. So just to give you an idea about how all of this went through. So we worked on this for about 6 months. This time includes also working on some other things and also refactoring our source code in order to work with interface instead of the base class and so on. And we published the first version of the source generator in November 2022. So this is the time that we published the first NuGet package called Realm Source Generator. Nowadays, we don't have a separate package anymore, but the source generator is already included in the Realm package. And we still support nowadays the classic model definition, so the one based on the Weaver, but we are pushing developers, at least we like developers to move the source generated approach because we would like to get rid of the previous model definition. The fact that we moved to source generators allowed us to work on some features that we wanted to work for some time, but it would have been particularly annoying to work with Weaver. For example, we added support for nullability, we added support for a new data type, and also we added support for serialization for a certain kind of serialization that allows to use Realm object together with the MongoDB API in an easier way. We're also planning to do new things thanks to the source generator, like the support for incremental generators that, without going too much into details, are essentially a kind of performance-aware source generator, where the source generation is not run all the time, but is run only when it's truly necessary. There is another thing that we really love to do, but it unfortunately doesn't depend on us, and that is completely remove IL weaving. So this is something that is obviously not in our hands and depends on the language feature. But this would allow us to remove IL weaving because if developers could define partial properties, we could go and define the setters and getters with our source generator and we wouldn't need the weaver anymore. As you can see, if you're interested about this, you can go on GitHub and vote for this issue. This is something that is actually getting more and more votes when I go and check it. Also because our use case, let's say, so the need to modify the setters and getters of properties is not something so uncommon with source generators. And source generators are getting more and more used, especially with the push to ahead of time compilation. So it's something that maybe at some point will come, but we don't have any particular power on it. But it would be really nice if we could remove completely the weaving by keeping the same developer experience. So sum everything up. So so we're using this code generation techniques essentially to hide the complexity of the Realm SDK behind the model definition, so that developers could work with C# object without needing to worry about how Realm works internally. In the beginning, we were using IL weaving for this. It is an extremely powerful technique, but it's also very difficult to use for various reasons. For this, we decided to move to source generator when they became available, that are a much nicer alternative and also much modern alternative, because this is also what the whole .NET ecosystem is pushing forward. Both these approaches have their own quirks and limitations, but overall we are pretty satisfied with the switch to the source generators because they allowed us to work on some features that we want to do for some time, and also will allow us in the future to work in a much easier way on this part of source code. So this part of source code related to the model definition. So we had this the surgery approach now available for more than 1 year, and we didn't get any complaints from our developers. So we think that this was a success, because from the developer point of view, maybe this didn't change much, but it was really useful for us because it greatly simplified our experience of working on this part of the source code. So yeah, this was my talk. And if you have any, if you want to know more about weavings or generators realm, I put some links in the in this link that is here on the bottom, or you can just write to me on Twitter, X, or wherever you find me, or obviously now if you have any questions.